What's up, everybody? It's Dan from sagemathtutoring.com and back with another video, this time covering some problems for the Hspt test, the math section in particular. So let's get started. If a plus 3 equals b plus 8, then which of the following are true? Well, let's see. What I would say is for this one, I would subtract 3 from both sides, and we would quickly see that a equals b plus 5. In case that's not clear what I did, I subtracted 3 from both sides, and therefore we know that a happens to be whatever b is plus 5. So a is going to be greater than b. So that should be the answer there. So that one's pretty simple. Looking at this one, in the HSPT, you're not allowed to use a calculator, so therefore we should approach this without a calculator. And it would be the case that it's 36.43 times 0.062. Now, I am seeing out the gate that there's going to be sort of 5 total decimal places, so that might be sort of helpful. So that's 2 right there, there's 3 right there, which means that that really should translate to 5 total decimal places at the end of the process. This one has 4, 1, 2, 3, 4. This one has 5. So I'm going to say answer choice B is looking really good because that's 5 total decimal places there. This one has more than 5. This one has 3. So I'm going to go ahead and multiply this out. Let's just take a look. So we have 3 times 2 is 6, 4 times 2 is 8, 6 times 2 is 12, carry the 1, 3 times 2 is 6, plus that extra 1 is that. Let's not forget this 0 that we're supposed to put there. 3 times 6 is 18, 4 times 6 is 24, plus that 1 is 25, carry the 2, 6 times 6 is 36, plus 2 is 38, carry the 3, 3 times 6 is 18, plus that 3 is 21. Adding all of this gives you 6, 16, carry that, 8, 15, carry that, 2, 2. And once again, we are indeed looking at 1, 2, 3, 4, 5 total decimal movements there. So that is indeed B. It does look like we could have just chosen B right away, actually. Okay, looking at 228, what is that? Well, the sort of rule when it comes to long division of decimals is you must be sure that this number doesn't have a decimal in it. So you're going to have to move this over 1, 2, 3, 4 spaces. But since you're doing that, you have to move this one over 1, 2, 3, and 4 spaces, which would give us like a 0 here and a 0 here. So we would have to sort of rewrite this situation. So it's 4, 3, 1, with 2 zeros, and then we have 2, 5, 4, 5, 5. All right. Now, already kind of an awkward situation, but at the end of the day, it's workable. So let's see, we have a 5-digit number here. We have a 5-digit number here. So yeah, 25455 goes into this how many times? It certainly looks like it would be like a round 2, but you know, this is what, 43,000 approximately. This is 25,000 approximately. So if we were to multiply 25,000, in fact, I'll use commas. If we were to multiply 25,000 times 2, that would give us 50,000. So we already know that it's going to be 1 point something. So we have 1 point, and then it's going to be some other stuff here because it's going to be 25,000 times 1. Goes into 43,000, but not over 43,000. Now, there is only one answer choice that features that scenario. That is answer choice A. So I'm going to actually say that we're done with this. If it was the case that you wanted to actually follow through with the long division, I'll just tell you that it would have been 25,455 times 1. So you would write that here. We have 5, 5 here. Let's sort of analyze this situation off to the side because it looks like we're going to be subtracting across zeros, and I kind of want to just focus on the intricacies of that really quick. So Looking at this, the 0 minus 5, obviously that's not large enough, so we would have to turn that into a 10 by borrowing here, but unfortunately there's nothing to borrow from because there's a 0 there. So we would have to borrow from here because there actually is something here. So this would turn into a 0. That would turn into a 10, okay? And good. So that turns into a 10. Now, with regards to this right here, we need to turn that into a 10. So what we're going to have to do is turn that into a 10, but this becomes a 9 as a result. All right. So once again, when you're subtracting across zeros, you have to kind of do that. Then we have 10 minus 5, so that's going to become a 5. We have 9 minus 5, which is going to become a 4. But over here, now we have a 0 minus 4, so we are going to have to borrow from the left. We would have to turn that into a 10, turn that into a 2. So it's going to be 10 minus 4, which is 6. And then over here, we have 2 minus 5. Obviously, that's not large enough. We would have to bump that up to 12 by borrowing from here. So that makes that a 3. So we would have a 12 minus 5, which is a 7, and a 3 minus 2, which is a 1. All right, so that's a little bit of old school subtraction. Now, the good news is you did not have to actually do that here because the moment you see that it's going to be 1 point something, it's answer choice A. Okay, problem number 230, solve for x. Radical x plus 6 equals 11. Okay, so for this, we should be subtracting 6 from both sides because we want to get that x by itself. We would be getting closer to that by getting the radical x by itself. At this point, we have radical x equals 5. Now, I call this radical. It is the case that this just means that it's the square root of x equals 5. And in order to get rid of the square root symbol, which is sort of our goal right now, we want to get rid of this blue square root symbol. In order to get rid of that square root symbol, we have to do the opposite of what the square rooting operation is doing. And the opposite of taking the square root is to square the value. So we're going to square not just the left, but also the right, because that's what you have to do in algebra. As a result of that, this exponent of 2, you can think of it as canceling the square root symbol, that blue square root symbol. And that leaves us with x equals 5 squared, which is 25. And that is most definitely right here. Okay, so with regards to this one, 232, I feel like an easy way of going about this would be to take note of what's going on with the units digits. All right. And the reason I say that is because I'm looking at the answer choices and notice how all the units digits are different. We have a 3 here, we have a 2 here, we have a 1 here, and we have a 0 here. So to me, that rings bells in my mind that says that there might be a relatively fast way of doing this. And that is indeed the case, because if you were to go old school with this, where you do 436 times 42, well, just keep in mind, there would be that moment where it's 6 times 2, and I think we all know that that's 12. You would carry the 1, you'd have blah, 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 blah over here. But then there would be that moment where you drop a 0 here, and then you would go through the motions, and you have blah, 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 and then you would add, and then right here would be 2 plus 0, and that would be a 2. And then you would have the rest of the answer, blah, 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 blah. But the bottom line is the only answer that has that units digit of 2 is right here. So I actually think we're done. All right. It is the case, however, that my student watching might want to be reminded of how this works. If you were to actually go through the process without using the shortcut, it would be 6 times 2 is 12, carry the 1, 3 times 2 is 6, plus that 1 is 7, 4 times 2 is 8, drop the 0 that I had mentioned before. Let's see, 6 times 4 is 24, carry the 2, 3 times 4 is 12, plus 2 is 14, carry the 1, 4 times 4 is 16, plus 1, and then we have a 7, so we have 2, 7 plus 4 is 11, carry the 1, 9 plus 4 is 13, carry the 1, 8, 1. So 1, 8, 3, 1, 2, and that is indeed answer choice B. Okay, so looking now at problem 233, let's see. 10 years ago, Sally's mother was 3 times as old as Sally. How old is Sally? Okay, so anytime there's an age problem, I like to do a little chart. There's two people here. There's Sally, and then there is her mother, okay? And in this particular problem, they have the past represented, that's 10 years ago, and then we have the present moment represented. So I'm going to sort of go off to the side and say past, present, okay? Now, then we can fill it in with information. So 10 years ago, Sally's mother was 3 times as old as Sally. So let's call Sally's age back then X. Okay, so back then, that's 10 years ago, um, Sally was X years old. Okay, and then, and in fact, I'll just remind us that's 10 years ago. I'm just going to remind us. And according to the information, in that moment in time, Sally's mother was 3 times as old as Sally, so we're going to call this 3X. All right. How old is Sally's mother today if Sally is 25? Well, we know that Sally gained 10 years, and we also know that Sally happens to be 25 now, right? And we also know that the mother uh, gained 10 years of age, so that's going to be 3x plus 10, right? And we want to know, well, what is this, right? What is this? Well, it would be nice to know what x is. And the beautiful thing is we actually have all the information we need right here to find x, because the reality is, as my student might be recognizing, is that we have 2 ways of representing Sally's current age. We could either call Sally 25 years old now because they told us that, or we could call it x plus 10, right? Because 10 years ago, Sally was x years old. Clearly, therefore, now Sally is x plus 10 years old. So you can go off to the side, set up a nice little equation, right? And then solve for x by subtracting 10 from both sides. And then I think you understand we would have 15. So that means that x is equal to 15. If that is the case, then of course we could go work with this. And it is indeed 3 times not just x, but 15 plus 10. And then we would have 45 plus 10, also known as 55. So that's the answer there. Tricky one, I would say. It might require sort of getting a little bit of practice with these age problems. So looking at the next one, what is the ratio of 3/4 to 4/8? Okay, so if they're asking for the ratio of 3/4 to 4/8, that's their way of inviting you to turn that into a fraction where the 3/4 goes on top and the 4/8 goes down below. Now it is the case that 4/8 is 1/2, but I don't know if I want to worry about that just yet. So let's see. So the reason I did that is because anytime you have a ratio written in this to form where they're using the word to, it is hopefully understood that the first number before the word to is the numerator, which goes on top, and the number that comes after the word to is the denominator, and that goes on bottom. And then it is the case that this is sort of secretly a division problem, where that's just going to be 3/4 divided by 4/8. Okay. Now, hopefully, my student watching recognizes that that is a keep, change, flip scenario. Anytime you are dividing fractions, you keep the first fraction as it is. You change the operation from division to multiplication, and then you flip the other one. So we have 8/4. Now, 8/4 is really 2/1. We could acknowledge that, but we could also sort of, recognize that we could just multiply straight across as well if you want to avoid confusion. So we have 3 times 8, which is 24. 4 times 4 is 16. It is the case that now we can reduce 24 is divisible by 8, and 16 is divisible by 8, so we could divide the top and bottom by 8. Next thing you know, you have 3/2, and that should be the answer, actually, and that would be right here.